Immersive XR experiences have been a hot topic of this conference, and your next talk is the second one on the bounce based around this topic. It's almost as if we have a huge paradigm shift in the way in which we interact with computers coming our way. Our next speaker probably hopes so, and also is probably responsible for part of that shift. Taken to the stage for the 2021 CityJS conference is Ada from London in the UK. Ada is a developer advocate with the Samsung Internet web browser, and in this session, Ada is going to be looking at how we can craft immersive AR experiences using the WebXR technologies. I've been looking forward to this talk all throughout the conference, and I'm sure many of you watching along at home have been too. Don't forget to keep your questions to one side and join us for the Q&A session, which will be starting on GatherTown immediately after this talk, as well as keep those comments rolling in on social media using the hashtag CityJS2021 and the comment section in YouTube. Ada, it is my honor, privilege and pleasure to hand the stage over to you.
I'm Ada Rose Cannon. I'm a developer advocate for the web browser Samsung Internet, and I'm co-chair of the W3C Immersive Web Groups. I'm here to talk today about AR in the web, but before I begin, a little bit about Samsung Internet and what that does. So Samsung Internet is an Android web browser. It's maintained by Samsung, and it's a fork of Chromium. It has features aimed at power users and people who are privacy aware. It's got like ad blocking, tracking prevention. It's got a fully customizable user interface. Like, I really like it. Like, I use it as my default browser, and I probably would even if, Samsung weren't paying me to promote it. So yeah, I work for Samsung. You can download it from the Play Store on Android, and I really recommend trying it out. If you're a web developer and you don't already test on Samsung Internet, please download it and test your websites in there. We may be a fork of Chromium, but we are only a fork. We're not like just a wrapper around native Chromium. So there will be a few small changes, and we have a lot more users than you would expect. As a developer advocate, my role is to help developers deal with the latest features in the web platform, to build websites which make the most of everything the web browser can offer. If you have any questions about Samsung Internet or WebXR, please reach out to me through email or social media. WebXR, at its core, is an API designed to access the sensors and displays of virtual reality and augmented reality devices. The X in XR just stands for whatever you want. So it can be X for VR, X for AR, X for MR, like MR is mixed reality. Like any of these terms, they tend to fall under the umbrella of XR. So that's why it's just called WebXR. By knowing what the user is looking at, we can render a scene using WebGL from the user's point of view. It can also be like WebGL2 or WebGPU, like this kind of graphics thing on the web. We can send it to be displayed on the device, and by doing this at the frame rate of the device, it gives the illusion of being inside a virtual scene. Here is an example of augmented reality in real life running on Samsung Internet. It's launched from a normal web page. It's rendered using WebGL, and it uses the WebXR device API to detect the user's environment, such as the carpet, letting us place this cactus on the floor. It can also detect things like walls and stuff like that, so I can place the cactus on the wall. Places like images or this patterned carpet make excellent surfaces for augmented reality. Alright, so I said what WebXR is, but why WebXR? Why does it exist? Why do we need it? So as its name suggests, it combines the web technologies and the XR technologies. And there are huge benefits XR can gain from being on the web. And also vice versa, benefits the web can get by supporting XR devices. By supporting these new devices, which right now are very niche, but over the coming decade may very well integrate into our lives. Just like smartphones have today, like smartphones over a few years went from something that was very niche to something that you can expect most people to own. And I expect as devices get small, as XR devices get smaller and more common and cheaper and more available to consumers, we're going to see the same thing. WebXR can already support a wide range of devices. Today I'm going to be focusing more on the augmented reality devices. So typically this means like handsets like mobile phones, which often have AR capabilities built in through their advanced camera systems. Most modern smartphones have some kind of AR capability. Also mixed reality headsets, which are kind of niche still. They're not very common and they're very expensive. And they're pretty hard to get. But over time, as these devices become more popular, and more content moves to these devices, if the web cannot work on these devices, the web will eventually cease to be a relevant content platform. So it's really important the web continues to work on these devices. XR technologies allow websites to do things that they could never do before, such as displaying content on the user's head-mounted displays, like giving them the sensation of being in a virtual environment, or detecting the user's real environment, letting our page's content interact with the real world. It lets us track the position of the user's head and hands in real time to enable the user to reach out and have physical interaction with our web page's content. We can render content stereoscopically in an efficient manner using the existing web's graphic stacks. Now, these are some really powerful abilities. And by bringing the content outside of the 2D monitors it's been in up till now, it can enable many new experiences that do not work very well if you just view them on a 2D page. So for example, it enables users to comfortably interact with 3D content. You can even put that 3D content into the user's environment, giving it context that is familiar to the user. So if the user puts a virtual bear in their living room, they can see how big that bear is compared to their real furniture, in a way that saying this bear is 2 meters long can never adequately express. It lets users explore spatial data in a more naturalistic fashion. If data is designed to be 3D, then interacting with it in a 3D environment just makes a lot more sense and is a lot easier than controlling it with a 2D plane. We just talked a lot about the benefits XR tech can bring to the web. But what about the other way round? What can the web do for XR? Well, most importantly, the web is the biggest software platform in the world. It has billions of users, many of whom are already using XR-capable devices, whether they know it or not, because a lot of this technology is just built into their smartphone, even if they don't use it on a day-to-day basis. A single XR-capable website built with WebXR should work on all kinds of XR devices with a single build, as long as the browser supports WebGL and WebXR. The WebXR device API has been cleverly designed to abstract away many of the differences between these very different kinds of devices, such that it enabled you to build an experience on one platform, and if you build it generically enough, it'll probably work pretty fine on any other devices, even if you are unable to test on one because they're not available to you. But there's also tools to let you emulate these kinds of devices as well. So you can get pretty far. This isn't just restricted to devices which you can't access. This is also devices which you can't access because they haven't been built or even conceived yet. The power of the web is that websites don't break every time you get a new hardware update or a new browser update, or you get a new device. Websites built 25 years ago still work today on hardware which was just science fiction when that website was made. So if you go on the Space Jam website today, it still works just as well today, aside from a few dead links, as it did the day it was built. Even though the hardware you're using it on will be inconceivable to the developers of that website. And the same is true for XR sites. The XR landscape is evolving extremely fast. We don't even know what XR hardware will look like in 5 years, let alone 25 years. So once the WebXR device is stable, in theory, a website you build then, like today, should work long into the future on whatever bizarre future hardware we're using then, provided that the web is still around. One really powerful ability for writing software on the web is that you don't need to download anything before you can run it. You don't need to install an app to view a web page. You just use your web browser. And it's the same with WebXR sites. They start quickly and they can progressively load the content so that a user can have almost instant engagement with an XR scene, and you can carry on pulling in content as the page is loading. It's not the best experience to do that, but you can do it. And you can shift stuff immediately. You don't need to wait for app stores to approve your app, or if it's the kind of thing that app stores don't even allow, you can still put it on the web. And you don't have to worry about app stores taking a cut of your revenue either. It's the web. You can just take payment through the web. You can build something and push it to a server, and you can have your users experiencing it immediately. They don't need to download anything. They don't need to wait. There's no approval process. You just make your HTML, JavaScript website, put it up there, people can use it. This is a really powerful feature of the web. The web is for everyone. One last thing I wanted to mention is that the web developer community is huge and is extremely active too. New libraries and resources are being developed continuously. The skills needed to build an excellent XR-capable site definitely lean more towards the web developer skill set than the graphic design skill set. Although experience in both is ideal, but there's nothing stopping person with one skill set learning a bit of the other one to have a go at making something. So I've talked a lot about the benefits of WebXR, but I want to talk a little bit now about how the WebXR standard is made. Because as chair of the group, it's really important to me to get more and more people involved, to get more viewpoints and input into the specs. And I hope to encourage you to participate. The WebXR APIs are developed totally in the open by the immersive web groups from the W3C. The W3C is the standards organization that develops many of the standards for the web. And the WebXR device API is designed totally in the public eye. It's done on the open web. You can read about it on GitHub. And you can see all of the issues and pull requests done in real time. Like it's all just done on GitHub. And you can read the agendas, the minutes, they're on GitHub too. You can view the code, you can view the explainers. Reading the explainers is actually a really good way to get an in-depth look at how the APIs work without going so low as looking at the raw implementer spec. Anything ending in explainer.md is a great document to read. They're just really interesting, if nothing else. If this interests you enough that you want to participate, and you can join the W3C Immersive Web community group. And the community group is open to anyone. And it's where the majority of the spec work for this API is done. There is another group, which is the Immersive Web Working Group. And the working group requires you to be an employee of a member organization of the W3C. It's where the specs are like polished up and finalized and turned into web standards, but not a massive amount of changes happen there. The majority of the bulk of the API shape is put together in the community group, where anyone can participate. As a group, we try to develop APIs which expose many of the latest XR features from the latest XR hardware. Many of these are based around giving a deep understanding of the user's environment. But it's a careful balancing act, because giving a deep understanding of the user's environment has clear privacy and security issues. And it's a fine line to walk to give users the high expectation of the security and privacy of the web with all the features we want to give developers. On top of that, we want to make an API that's going to encourage developers to build something that's accessible by default. And I don't think the WebXR device API is there yet, personally. I think we need more documentation around building accessible WebXR sites. This is kind of difficult because it's made with WebGL and WebGPU, like very low-level languages. You have to rebuild all of the accessibility stuff yourself. Nothing gets provided for you. This can be quite a lot of work, and a lot of developers don't bother. And so this is something which we really need to encourage people to do. We also try and weigh the APIs about how well they integrate with other existing web features. Like if something we want to implement is already partly implemented in another group, we try and work with them to make sure that we don't step on their toes, or we use their API to provide the surface for our API too. And finally, the most important thing is making sure what we build is future-proof. Because if we just try and stick in a single API from a single platform, this might be the kind of thing where it's the right choice for right now because it's what the hardware can do. But long into the future, this particular hack or workaround isn't viable anymore, yet it's going to be stuck in the web for a long time. Because the web doesn't like to deprecate APIs if it can avoid it. And so everything we build is going to be around for a long time. And this is already a pretty big spec. So we've got to make sure that everything we do doesn't clutter up the web. Because also large APIs make it slower to support and build the web browsers. The more interleaving standards you have in the browser, the harder it is to add other features to the browser. So making sure it's as good as it can possibly be is extremely important. The working group includes participants from Google, Apple, Microsoft, Intel, Mozilla, Samsung, all for many different reasons. So some of these companies have browsers, some of them have hardware, some of them are building XR software and want it to work as well as it can on WebXR. All of these people working together ensures that the API is designed in such a way that it will work well for everyone. And this is the most important thing about spec work, is that as long as many people get involved, then the API will hopefully work for many people. And that's what we want. We don't want to be an exclusionary platform. I want to talk about now about realistically what it looks like today to build an XR site, like what hardware you should support and that kind of thing. And this is very much skewed for today and not the future. And so I showed you a demo earlier of like a real device running WebXR. And this is what I'm going to talk to you now is a bit more general than that. So the first thing we want to look at is handheld augmented reality. This is the most common type of XR platform available today because many people already have an XR capable phone to do augmented reality with. And so if you want to reach a lot of people, this is an important form factor to support. The display, unlike virtual reality, is held in the hand. But the hand is also where the controllers are going to be. And if you tap the screen, you probably want to know where that's going to be in virtual space. Fortunately, you don't need to know the screen size or the tap location to work that out. The API handles it for you. When you tap the screen, it gives you a special transient input, the position of which is your finger's position in 3D space, which I think is kind of neat. The next most common kind of thing you'll encounter is head-mounted virtual reality. The most common device for this is right now, like today, is the Oculus Quest 2. This was an incredibly popular device when it came out near the end of 2020 and has many, many people using it. The display is on the head because it's virtual reality. You're looking through the user's point of view. If controllers are available, they're going to be held in the hand, or it might do hand tracking instead. So it might look at the user's hands and show them. But aside from hand tracking, there won't be any kind of environment sensing. Like you won't know the size of the user's room. You know the shape of the bounding box that the user's in, as a good example. But so you can place stuff like in the user's rough area. You won't be able to detect specific walls or floors or anything like that. Then you have head-mounted augmented reality, in which the display is on the head. The controllers, if available, will be held in the hand. It might do hand tracking. There might be like no hand or controller tracking at all, but there's probably going to be something like that. It can probably do some kind of real-world tracking. Like some headsets are designed to be like hand tracking only, like the Project North Star, and some are can do full real-world tracking. But generally, head-mounted AR can be considered as like the best of both worlds of AR and VR. And although it's a very niche piece of hardware at the moment, like it's hard to get and it's pretty expensive, like probably over the next 10 years, it's probably going to be the most common way that people deal with XR. As the headsets become cheaper, there are more consumer headsets. So if you want to build something that's really future-proof, you should probably also target this. Unfortunately, testing on these headsets is kind of tricky right now. I put together this Venn diagram to try and help pick like what form factors you should support depending on what you want to build. For example, if you need hand tracking, then you should look at headset AR and headset VR because they're the ones that do hand tracking. If you need to engage with users' environment, you should do headset augmented reality and handheld augmented reality. If you just want to reach as many people as possible, you should do handheld augmented reality and headset virtual reality. At least that's what the market looks like today. But if you're supporting those two formats, supporting headset augmented reality in addition probably won't require many, if any, code changes at all. And that will ensure that whatever you build will continue to work long into the future as more and more of these devices become available. Now I understand this Venn diagram is pretty complex, so I wanted to give them some specific examples to help illustrate it further. First, an example drawing application. So this needs hand tracking. So you need some kind of head-mounted device so the user's hands are free so they can draw. So head-mounted AR or head-mounted VR seems perfect. And you don't need specific access to the user's environment, so virtual reality is okay. So if they're on an AR headset, you just let them draw in their environment. If they're on a VR headset, you give them a virtual environment to draw in. You don't just put them in an endless void and for them to draw in. You give them a floor and maybe decorate it a bit to look nice. But then let's talk a bit about progressive enhancement, because you don't want to totally exclude handheld AR. For one, it's the most popular way that people can do XR nowadays. But even though they can't do the primary method of engagement, they can still engage with the content that people make. So for example, you could let them view the content that people have shared on social media. So I put on my fancy AR headset and I draw a pretty 3D penguin in my living room. I then save it to the server and it gives me a link. I share that on social media. Someone opens it on their phone and then they push a button and they view it in their living room. And that's exactly what you want for working across on many platforms. And that's kind of what progressive enhancement means for like XR devices. So you do what you can with the abilities that are available, especially as many different devices have a very mixed bag of abilities. Here's another example. Previewing furniture. So this is the kind of thing where you have an online store and you want users to be able to view the furniture from your store in their environment. So for here, AR is essential. So we'll want to do some kind of headset AR or handheld AR. And we don't need hand tracking because they're not going to be reaching out and grabbing the furniture. Maybe you want to add that as like additional features if you detect hand tracking is available, but for the basic thing, you just want them placing an object in their room, and handheld AR is good enough for that. How would you progressively enhance this? For virtual reality. So handheld AR, whilst good at doing AR, it's not immersive. It can't give users a sense of scale compared to themselves because it's still viewed on a 2D screen. So progressive enhancement for VR means that you can provide for them a full back environment. So instead of their living room, it's just a generic virtual reality living room they can view the furniture in, so they can get a good feeling for the scale of it. And that'll be a nice way to improve it for VR. And that wouldn't require much additional code. That would just be when they enter a scene and you detect they're doing immersive virtual reality, you just render an additional background scene for them. Like you download a 3D model of an environment and display it. My final example is a XR promotional website, essentially an advert. And you want to reach the widest possible audience. So you must at least do handheld AR, as today that's the most used AR device. VR is the next most widely used, so you probably want to do something there too. Like if you're supporting VR, but you can also support augmented reality, then it's probably not going to be too much of an extra step to ensure that it works for head-mounted augmented reality as well. And that way you can ensure that it will continue to work long into the future. I now want to go through some of the questions I receive the most. The question I get asked most is a two-parter. The first part is, what is WebXR best for? Well, firstly, simple single environment experiences. You don't want to be doing large experience with big downloads where the user's going to be looking at a really long loading bar. Like, users get frustrated and drop off after waiting for a few seconds for an ordinary website. Just because your website is virtual reality, they're probably not going to wait too much longer. Like, users have a really short attention span. So keep it simple, small models, optimize your textures, like really optimize your stuff, make it as fast as possible. Anything where you want instant engagement, so you want users to go from your website into the content without any steps in between. So if the maximum number of people is important, WebXR is good for you. Because if you go to an app store to download it, like every time they have to change screen or click on something, you're going to lose users as they get distracted and go do other things. So if it's incredibly important with you to just reach the most number of people possible, then WebXR is what you want. If it needs to be shareable on social media, then WebXR is fantastic because the content is just a URL. People can share that URL and then they can view it on a totally different WebXR device. And that's really neat. If you want to reach every single headset and you're not targeting a single specialized device, then WebXR is what you need. Because WebXR is designed to work on any device, including devices not yet built. In summary, reaching millions of people is more important to me than only a few users doing long-term engagement. WebXR is what you want. The people using WebXR generally won't be using a site for a long time. They might only be using it for a few minutes. And by being on the web, users know they won't have to clean up anything afterwards. They won't have to uninstall an app to free up space or anything like that. So that's really nice. Finally, the bit where I'm going to be brutally honest, what is WebXR bad at? So WebXR is bad at large multi-environment scenes. So if you have a large game where a user is traveling between lots of environments, doing lots of dynamic stuff, where with huge amounts of animation assets and textures and huge 3D models and big detailed things, like things can be large in VR, but also be low poly, so pretty cheap. But things can be like small but incredibly detailed, or just incredibly detailed in general, and that's expensive. The real key of like good VR stuff is creating the illusion of lots of detail without having lots of expensive effects. So if you need to do expensive shaders or anything like that, WebXR might not be ideal. So WebGL and WebGL2, they are an abstraction layer over the graphics library for your card. And so you won't have quite as good performance as you could get building in native. The upcoming WebGPU should help even more with this, so you can get like even more performance out, but it hasn't quite landed everywhere yet. But hopefully in the future this will be less of an issue. But still, one thing you can't get around is that if you have like large textures and large 3D models, this is not for you. Either try and optimize this away, or try to maybe split it up over several XR scenes and have like the user changing page between them. Because you don't want the user landing on your page, downloading 200 megabytes of assets, getting bored at 180 megabytes, and they've just wasted a bunch of data and battery power, and they didn't even get to see your stuff. And finally, if you only care about targeting just a single specific piece of hardware, there's not even any point of supporting WebXR. Like, the main benefits are being able to support many pieces of hardware. So if you want to support one specific thing, you can just ship it to their app store. And that way you can just ship something that's many hundreds of megabytes. You don't need to optimize it, just like slap it up there. Because then the users don't have a choice. Like, it's on one piece of hardware, that's where they get it from. Alright, so if that hasn't put you off anyway, so you think, yay, WebXR sounds great, it's just the thing you need, you want to reach millions of users and do huge things. But you're a graphics engineer, you've never done anything in the web before. How did you get started? Well, if you've used Unity, there is the Unity exporter. It's very good. But the resulting download can be pretty large, and it needs to be downloaded fully before the user can play it. And this means they end up staring at a long loading bar for a while. It's not the best experience, but it's a good way to try getting something onto the web. If you want something a bit more webby, then check out 3.js or Babylon.js, which are both excellent JavaScript 3D engines with WebXR capability built in. Alright, conversely, WebXR sounds great. I really want to do cool graphic stuff and I want to do virtual reality, but I'm a web developer. I've never done graphics before. How do I get started? Well, my recommended way of getting started here is probably A-Frame. A-Frame is a really good way to build WebXR out of HTML elements. And I don't mean like divs and spans and stuff like that. Like, these are new HTML elements that are custom elements for defining stuff like spheres and cubes and 3D models and animations and that kind of stuff. And it's really good. And you can write HTML that looks like this. So this is like 14 lines or something. And it's ready to go out the box, VR ready, and AR ready too, 3D scenes. It's really cool. And it's a nice abstraction layer around 3JS so that you can write HTML and you get this. But if you want to delve in deeper and like write some fancy 3JS code, you can do that too. Like, it's got enough hooks that you can do that, and it's really nice. And I have a graphics background, but I probably use A-Frame more than any other 3D library because I really like that method of authoring, like writing the HTML to describe the scene. And if I need advanced behaviors, I write them myself. If you're more of like a React-focused web developer, there is a 3JS wrapper for React called React 3 Fiber. And I've never used it before because I don't use React myself. But if you want to use it, please check it out. But I'm not sure if it supports WebXR out the box. You might have to build that in yourself. I haven't checked. I really don't know. But it's worth checking out if you like React stuff. Alright, so next question. What is the support for WebXR like? And the answer is, it's complicated. Depends on the operating system, the browser, the hardware. Generally, pretty good and improving rapidly. Like, for example, Apple just announced that their WebXR support is now in development, which is fantastic to see and makes me extremely happy. If you want more detail, I maintain a table of supported like web browsers for different features in WebXR on immersiveweb.dev, which is a great resource for WebXR stuff. The next question, can you access the camera feed in augmented reality? No, for privacy reasons mostly. With We may do some kind of limited access in the future. Like, users really want to do image recognition, they want to do face recognition, or do like special face effects and augmented reality filters, or do image marker tracking, so you can say scan a label on a bottle of something and then have it turn into a nice animated 3D effect. And this is a really frequently requested feature, but we don't want to give raw camera access because people don't like having cameras peeping into their homes. So we're thinking of trying to like do ways that are privacy preserving abstractions of these different use cases. What we do is still very much up in the air. It's early days for this kind of feature yet, but it's something that we know people want and is high priority for us. The other high priority feature is HTML. Like, can you use HTML in XR? Not really. Like, you can do hacks. Like, you can render HTML elements onto a HTML canvas. You can use that canvas as a texture, which you can then render using WebGL and display it in 3D. And then when the user clicks on that plane, you then work out the 2D position where they clicked, and then you map that back to the particular element on the HTML, and then you do a click event on that element. It's not a great hack, but it works, and with WebXR layers, it even looks pretty okay now. It's not ideal because it's not accessible out the box, and it's really important we have some accessible ways of doing HTML and CSS interfaces in WebXR, because HTML and CSS is a really powerful way to do 2D interfaces. And so this is an incredibly important feature which we are working on. There's an API called the DOM Overlay API that gives you like part of this support for handheld augmented reality, but and it's good and it works. But nothing for like VR or like headset mounted stuff yet. So again, can you use WebXR with Unity? And I wanted to re-announce this because I get this one a lot. Yes. Like, I have instructions for how to do it on immersiveweb.dev. Like I said earlier, it's not my recommended workflow. Like, the output is big and slow to load, but it does work. And people have done some really cool stuff with it. Like, this person here managed to port Tilt Brush with like the famous VR drawing application to the web through the Unity exporter and like some tweaks and stuff, which is amazing. That's incredible. So fantastic job there. And the final question is, do we have any connection to OpenXR? The answer is generally no. There's not really a connection. Like, there is overlap in the people working on the standards for both. The XR community is pretty small. Everyone knows each other. Like, we sometimes look to OpenXR to see how they solved an issue, or if there's like similar naming conventions, but there's not really any real connection between the groups. Some WebXR implementations are built on top of OpenXR, so like a platform built on a platform, if you will. So if there's a platform where OpenXR works, there's probably a WebXR implementation that will work there. So that's pretty neat. So I just want to thank you so much for listening. So here's the contact details again. So if you want to reach out to me on Twitter, reach out to our team on Twitter or an email, please do so. I'm always happy to hear from people. If you build something, please send it to me. I love seeing what people have built and trying it out. It makes me really excited. Anyway, thank you so much. I've been Ada Rose Cannon, and this has been doing augmented reality on the web. Thank you. Bye.
Ada, thank you very much for delivering such an amazing and interesting talk on how we can craft AR experiences on the web thanks to WebXR. I'm sure everybody at home will be joining me in giving you a huge round the world round of applause. If you have any questions for Ada, you're in luck. Our Q&A session is about to start over on GatherTown right now, so please do join us and pose your questions about AR and WebXR more generally to Ada. If you're not on GatherTown, you know what to do. Post along on Twitter using the hashtag CityJS2021, and if you are so inclined, use the comment section of YouTube to keep engaged with the rest of your fellow audience members. See, Harry Potter. Ada, thank you very much for that amazing talk. It seems like AR is quite popular with our audience. We've had a few questions come in, but first, how did that talk go for you?
It was really good. It's one that I'd been like working on for a while, and it's WebXR is in a really good state right now. There's lots of really exciting things happening, lots of new features landing every week. So unfortunately, it's making it very difficult to reuse any content since the whole landscape has changed every time I give a talk. But that
But
one went good, I think.
sounds like perfect situation for somebody who does conference-driven development.
Exactly. Every time you'll hear a new talk about WebXR, there'll be a new thing to learn about.
Yes, that's what we like. So we've got a few questions in here, and I think some of them are quite rapid fire
Hmm.
questions. So we'll get onto them. Is the Samsung browser available outside of the Google Play Store, F-Droid,
It's
for example?
it's on. So the official ways to get it are through the Google Play Store or the Samsung Galaxy Store. Unofficially, yeah, you can probably find it on an APK Mirror or something like that, but I cannot endorse those because I can't guarantee its installation.
No,
But um, it's out there.
it's out there, so you'll have to hunt yourself.
Yeah.
Excellent. The next one is about AR, which is handy.
Hmm.
Would you recommend marker-based or location-based AR?
So interestingly for this, marker-based AR tracking isn't available through the WebXR device API. Um, so if you wanted to do something marker-based, you'd have to use something like ARJS or something like that. But the result isn't that great. It means users have to print out a marker as a pain in the ass. When it's a bit easier just to use something like space-based, where it scans your environment and then you place something into your room without any kind of marker. And it's what WebXR supports out the box.
Perfect. So it sounds like that's the direction to go in. It sounds easier for developers and for
Yeah.
users.
And there is something which, like, it is a feature that has been requested for us a lot through the immersive web groups. Um, it's it's a feature which is really great for like advertisers. So they can have you can have your product and then the user can point at their product, it will detect a marker and then do some kind of cool augmented reality.
Yeah.
But this kind of feature is a very sensitive one to expose. With WebXR, we're trying to actually be a less dangerous API than raw camera access. And so just to give users more trust in doing AR in the web, because generally people don't want uh, malicious websites to do 3D scanning of the environment they're in. That's that's not a great thing to have in a website. And so we try to be very careful with the abilities we give through WebXR, and marker tracking is one of the ones that could be potentially very dangerous. For example, like a very stupid example would be you make a marker out of $100 bills, and then you wait until someone scans a whole bunch of $100 bills through the app, and then you'll be like, I should rob that person because they have a bunch of $100 bills lying around. That would be a stupid example, but the kind of thing that you'd want to avoid. And so dealing with these privacy things is kind of tricky.
Hmm. I'm interested now. What other requests have you kind of pushed back on in order to maintain that privacy focused direction that you're going in?
So most of the computer vision features right now, they're kind of difficult to do for privacy, which is a shame because it's like you can do really powerful things with just raw camera access. And we'd love to expose that. And it's what a lot of AR developers building really advanced products will expect. But being in the web, there is that lower level of trust. And so we have to be a more aware API. And the other thing, which is really surprising, is navigation. So for example, you go into one site, you enter virtual reality, and then you press a virtual reality link, and you go to another site while staying in virtual reality. And this is actually something that's really difficult to do because the website could do something malicious, like it could spoof a virtual reality browser so that you think you're using the normal web through your VR browser, when actually you're inside a different website. Because it's fully immersive, you can't see the URL bar, so you don't know where you are. So if you try to do something like online banking through a site you've navigated through virtual reality, it's hard to tell whether you're using a real browser or a fake browser. And it's a surprising feature that seems very basic and very simple. And it's one that's fundamental to the web. Like a web without links isn't really the web. Um, and so we have like some things where you can travel within the same domain through while staying in virtual reality. And there's a prototype implementation of that in the Oculus browser. But right now, it's not like a feature we've got yet. And it's one that I think is really important if we can work out a privacy preserving way to do it.
It's really reassuring to hear that you're putting privacy at the forefront of this stuff, because there's so many avenues, like you've explained a few, that can be dangerous in very real ways. You know, like stealing people's bank account details. That's a very
Exactly. Yeah.
dangerous thing. Um, one of the things that I'm interested to know, and this is a personal question to you rather than kind of the web AR people,
Hmm.
XR people. If you had a blank canvas, what kind of features would you like to introduce into WebXR? Is there something that's on your wish list which you think that's never going to go in there, but I would love it to be in
Um, there is a lot of these kind of features. So navigation actually is one I really want. Like it's the feature where I really want it to happen. The nice thing about being chair is that I can keep making sure it's brought up on all the agendas. But that's my like pet feature.
there?
I'd also really love to see more features to enable like cross-site social VR stuff. So, for example, if you wanted to have two users talking in virtual reality, you'd have to set up some kind of WebRTC link between them. Um, and having some kind of persistent avatar between sites would be really handy. So it would be really great if this was the kind of functionality you could actually get
Hmm.
from your web browser. And so you could just land on a site and the site can request like an opaque blob, which can be rendered and sent to other people so that you could maintain a consistent avatar through across many sites without needing to build it on a per site basis. And there are tools like readyplayer.me that's kind of like that's on the building steps for this.
Hmm.
And it's cool to see. And the last thing I'd love to see would be launching augmented reality immersive sessions in a virtual reality augmented session. So like layering them and stacking them. So you could go into virtual reality, be in a virtual reality environment, then open up a new web browser window in that environment, load another page with some augmented reality content, say like a 3D model telling you what the weather was, and then placing that in the virtual reality environment, even though it's from a completely different site and they are unaware of each other. And that would be, I think, the bee's knees. Um,
That would be the bee's knees. I will admit, I think Gravatar for AR sounds kind of a bit more useful to me, like as an end user, but they were all
Yeah.
exciting features. I'm sad to say that we've come to the end of our time, but I've got one rapid fire question for you
Hmm.
before we wrap it up. And we're kind of surveying the developer landscape at the moment. See what's the cutting edge trends with this kind of thing. Tabs or spaces?
Tabs. Definitely. Tabs all the way.
Tabs all the way. That's a controversial opinion amongst our speaker lineup, but it seems to be a popular one today with our speakers. Ada, thank you very much for your time, effort, and energy in giving that talk and this Q&A. We could probably rabbit on for hours, but unfortunately we can't. So it just leaves me to say thank you for your time, and hopefully you enjoy the rest of the conference.
Thank you so much for having me. It's been really good.